In this video, we are given a system of linear equation with two variables, and in one of the equation there is a parameter a. The question is, for what value of a will the system have no solution? Good. We are going to solve this question by different methods. The first one is to solve and find the solutions in terms of a and see what happened. Good. Now we solve this by elimination. Good. Now we can see that we have 2x here, negative 3x here. So if you multiply the first one by 3, the second one by 2, so the first one, number 1 multiplied by 3 gives me 2x multiplied by 3 gives me 6x. So I am multiplying all the terms here by 3. So the second term will be plus 18y equal to negative 6. So 2x by 3, 6y by 3, and minus 2 by 3. Now the second one, I'm going to multiply it by 2, because this 6 with the 2 here, 2 times negative 3 gives me my minus 6. So equation 2, I will multiply it by 2, and that will give me minus 6x plus 2ay equal to 8. I multiplied all the terms here by 2. Negative 6, 2a, and 8. Good. Now we add the left side, this side here with this side here, and then equal this side here plus this side here. Now when we add, look, 6x, negative 6x, it gives you 0. So what is left here? It's 18y plus 2ay. And the other side, negative 6 plus 8, that gives me 2. Good. I can solve here for y. Now this is y and this is y, so I factor. That will give me 18 plus 2a equal to 2, and that gives me y equal 2 divided by 18 plus 2a. Now when do you think this solution will have no meaning? It won't be a real number. Now we have a division here, so if this quantity is equal to 0, we cannot find the solution. No solution if this quantity equal to 0. So 18 plus 2a, we solve it, equal to 0, and that gives me 2a equal negative 18 and a equal to negative 9. So for what value this system of equation has no solution? For a equal to negative 9. This is one way to do it, and we don't need to go any further, because if you cannot find y for the system, you will not be able to find x. The second method we are going to use is the method of the determinant. Now let's review this first. And so to solve a system of equation using determinants, first we define a determinant d. The determinant d, it's made up of the coefficient of x and y. So 2, 6, and then negative 3, and then here a. Negative 3, and then a. Now let's review this. Now the determinant of a, b, c, d, it's equal to ad. So you cross multiply, a multiply d minus bc. So this is just a quick review. So here we will have the determinant 2 times a minus 18, that's plus 18. You define two other determinant, dx. Dx is the same as this. You just replace the coefficient of the x by the constant. So minus 2 and 4. The constant goes here instead of the x. And this constant goes here, 4. And then the rest unchanged, 6 and a. 6 and a, they stay. And the determinant here, it's minus 2a plus minus 24. Then you define dy. From the main determinant, this time you replace the coefficient of y by the constant. So these stay the same. 2, negative 3, and then the constant minus 2, 4. Again, you replace the coefficient of y by the constant. This is the dy, and this will give me a number. So 8 minus 6, that gives me 2. Now, how do you find x and y? X is dx by d, and y equal to dy by d. Now let's look at dy. Let's look at y. Y here, to calculate y, what we need to do is to divide dy, which is 2, divided by d, which is 2a plus 18. Again, for this solution to be a real number to exist, this must be non-zero. So if it is 0, there is no solution. 2a plus 18 equal to 0. So this will give me no solution. And when I solve this, that will give me a equal minus 9. Same thing as before. When a equal to minus 9, the system of equation has no solution. The third method, it's a graphical or geometrical solution. We are going to use some analytical geometry. Now, when you have got a system of equation, a 2 by 2 system of equation, when you graph each equation, they're going to give you a line. And the system will have a solution if the two lines intersect, and the point of intersection, xy, is in fact the solution to the system. Now, the two lines may not intersect at one point, and therefore no solution if the two lines are parallel and they have different y-intercept. Now, two lines are parallel if their slopes are equal. Okay, good. Now let's go back to our equation and write each one of them into slope-intercept form. So 1 gives me 6y equal negative 2x, negative 2. Remember to write a line into slope-intercept form. You solve for y. And this is what I'm doing. I divide by 6 everywhere. And that gives me y equal 2 over 6 can be simplified to 1 over 3. So negative 1 over 3. Same thing here. There is an x. Negative 1 over 3. So this is line L1. And M1, its slope is given by the coefficient of x. This is the slope. It's minus 1 over 3. Good. Let's go to line number 2 and do the same thing. Solve it for y. Now, line number 2 gives me the following. Ay is equal to 3x plus 4. Divide by a. Simplify. That gives me my a. So we have the slope here, m2 equal 3 over a. Now we need, so we have no solution if m1 equal m2. Good. Now let's put m1 equal m2. When we solve this, so we cross multiply, that will give me a equal -9. Now here it's not finished, because what we need to do is to check that the y-intercept, which is here -1/3 and here 4/a, are different when a equal to -9. So now this is known. So the y-intercept here, it's -1/3. It's a number. But here it's not known, so we need to calculate it. So 4/a, when we substitute a by -9, it will give me -4/9. And this is different from this. Therefore, if you graph the two lines for a equal to 9, they are parallel and they have different y-intercept, and therefore no solution. So again, we find a equal to -9. We have used different methods just to show that in math sometimes problems can be solved in different ways. But here I think the most important part is the graphical solution to this problem, which takes you to review several concepts like the slopes, the y-intercept, and so on. And this is also a good view, a good interpretation for system of equations for linear algebra.